Hi, welcome everyone. In this video, I'm going to show you how to estimate the error correction equation in Stata. In the previous video, we talked about what is the background of error correction models. Its link is provided in the description. And after this video, I will also share the link for error correction models in R. So in this example, I will start from the base data file and I will discuss in a way that is not difficult for the people who are new for data analysis, especially for the time series. So the data file that I have is for the case of Pakistan, data from 1960 onwards to 2023. There are some missing values, so Stata will automatically pick the minimum data that is available. For example, if I select the data for ICT, it will start the analysis from 1984. If I select data CDD or SDD and remove ICT, it will start from 1975. If I include the data of EPC, it will start from 1971 and so on. So these are some variables. So first of all, we have to declare that this is the time series data. For that, the command is TSSET here. So Stata will know that it is the time series data. Now I need to show at least one of the variable is non-stationary. So I will go in statistics and in time series data and in the unit 2 tests, and I will select one of the dependent variable from here, that is GDP per capita, and 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 I will also want to show the regression table. Okay, so when I run this command, it is estimated at lag 0 and it is insignificant. It means it is non-stationary. So if you want to know how many lags you want to keep, so for that command is var GDP PC. So when you run it, it will show you that the major stars are at lag 1. So it means when I do page up, and I should be estimated at lag 1. Okay, and it is still non-stationary. Now next thing is you need to have a look if you need to do the unit to test at with trend or without trend. So for that you usually um, have a draw the graph for the time series variable. So its command is ts line or line GDP here. So when you run this command, it will show you the time series graph for GDP. Now, if the data has a positive trend, it means you should include the trend variable. If the data is not increasing or decreasing, rather than it is just changing around similar horizontal line, then you can use without trend. Okay, and you can also notice that it does not start from 0. Okay, currently we don't know it is starting from 0, so we should include the intercept. Okay, so I will do the page up and add trend in it. Still it is non-stationary. So these are the way we usually select the unit to test. I have talked about the lags, and I have talked about why we include the trend or not and how to find the lag order. Now, since at least one of the variable is non-stationary, we should do the error correction equation, assuming that you don't know the advanced models which are already there. So what I will do, I will run the red command GDPPC, and I will use EPC and PD and CDD. So I will include these three variables. I will run the regression. So I need to make sure that the spellings are correct. So I estimated this model. So first of all, you need to make sure your variables are significant. So I will try to remove some of them and make sure that they are showing significant results. Now my variables are significant. Okay, so these are the results for simple regression. Here one of the variable has very high t-value, and you see R square is high, and it is giving us a hint that the results are very good. So we need to first of all make sure that what is the value of Durbin Watson. So E stat the Watson, so its value is 0.3. In the previous video I talked about that if the Durbin Watson is smaller than R square, it is a hint that the regression can be spurious, but it is not confirmed. For that, you need to make sure that there are two or three steps. First of all, you will generate the residuals. So I will run the regression again and predict residuals resid. Okay, I will make it smaller name. Predict res. So there is a new variable here. So these are the residuals. So I need to now make sure that this residual is stationary. So I need to do the unit to test. Before that, I need to know what is the lag order. So var sock res. So it requires lag 1. So I will go in the unit 2 test, time series analysis, and test augmented Dickey Fuller. I will select the residuals, okay, and this regression tables, and I need to add lag 1. So this is, it looks like it is non-stationary here, okay, but you need to add do few things. For example, let me show you the graph TS line RES. So it is there is no trend, so I should not add the trend. Secondly, it is deviating around 0, so I should, theoretically there should not be an intercept in the model, because we assume that the error term has 0 mean, so we cannot add intercept. Secondly, in the regression you can see the intercept is insignificant, so I will bring it up and add no constant. So when I run this, you can have a look that the test value is bigger than the 10% level. So it means that at least at 10% the residuals are stationary. So because the example is made impromptu, so we can assume that at 10% the residuals are stationary. Now we need to check for co-integration. The first way is the E-Granger test command is this, but before that we need to know how many lags we should keep. So I will start with var sock. For all those variables, it is saying that the majority stars are at 3 and 2. So for simplicity, I will start with 3 and then have a look at 2. So I will run eGranger lags 2 and ECM. So when you run this, it will create an ECM equation in the background automatically. I will show you how it has made, but we will do it ourselves too. So this is a two-step ECM. What is it done? It has estimated the long-run regression equation, generated the residuals that we talked about in the video, and created its lag, and then first differences of the independent variables after lag 3, lag 2 as we talked about here. So you have a look at ECM value, which we talked about in the video, that it should be negative and significant. This is a hint that there is convergence and the long run equation is not spurious. Now we need to confirm it. For that we'll do page up and remove the ECM and run it again. So that the value that is shown here, it is smaller than the critical values. So this result is saying that there is no integration in the equation. So it is hinting that the results are spurious. So if this test value is bigger than the critical values, it means it would have been significant and there is co-integration. Why it is so? Because our unit 2 test was also saying that there is a weak co-integration and it is insignificant at 1%. And other hint can be that there is no stronger relationship between the variables. Now, even if we want to create the residual ECM equation, I will show you the example. So we have already generated residual from the long-run equation. Now I will do reg d dot gdbpc. I will have a look what variables we added: d dot hdd, d dot pd, d dot cdd, and l dot res. So this is the ECM equation. First differences of the independent variable that we used, and the lag of the residuals. So when we run it again, so at zero lag order of the ECM equation, there is no convergence because the ECM is insignificant, and I should add the lag of PD because it is significant. So I will go it up and I will add d dot PD and l dot d dot PD as a new variable. So still it is not significant and I cannot add theoretically more lags because all of them are insignificant. So these results show that and overall f-test is insignificant now. So these results show that there is no co-integration in the models. So I hope you understood the structure of ECM equations, and those people who are not expert in time series modeling and you are starting their research, they can start with this ECM model. And this model, the same process works for panel data, but only difference is that you have to declare it as a panel data and use the panel data unit to test. And lastly, when you complete this ECM equation, you need to make sure that it doesn't have heteroscedasticity, multicollinearity. For that, the commands are estat het test, so there's no hetero, and then estat VIF. It is saying there is no VIF because none of them is above 10. Then estat, and then for reset, I need to have a look what is the spelling of the command, and then estat D Watson. It is not valid because it is not applicable if there is at least one lag in the model, but it is still higher than the previous one. And then you can go here for more diagnostic test equations. So in regression other, in the regression, simple regression, and then specification tests, you can apply all of them which are shown here. And I need to go for the advanced autocorrelation test, that is Godfrey test, and it is saying there is no autocorrelation at lag order 1. So this way you can add more lags. Technically there should not be autocorrelation at lag 1 because lag 1 is already there in the model. I can go there and have a look at lag order 2. So Godfrey and specify lags. I will say lag 2. Okay, and then when I run it, so it is only doing lag 2. So what I can do from lag 1 to 2, and I can add more lags like 3. So this way you can check. So this was the tutorial for how to estimate ECM equations, and in this example I tried to highlight all the problems that can occur, but I also showed you how to check it if the residuals are significant at lag here in the manual ECM equation, and the angle Granger test is showing significant results, and the unit 2 test of residuals are showing significant results, means residuals are stationary, then it is a signal that there is a valid long run relation that we showed with OLS equation like this. Okay, so thank you very much for watching. Do have a look at the links in the tutorial for background and further details. Thank you.